Hi, Professor. Our topic is to study risk factors for heart disease. Firstly, I will introduce our research background of our topic and our dataset. So for our dataset, the target variable is heart disease. According to the Centers for Disease Control and Prevention, heart disease is one of the leading causes of death in the US. About 47% of all Americans have at least one of three key risk factors for heart disease: high blood pressure, high cholesterol, and smoking. Next page, please. Other key indicators include diabetic status, obesity, not getting enough physical activity, or drinking too much alcohol. Therefore, researchers collected data from the 2020 annual CDC survey data of 400,000 adults related to their heart disease. The original dataset includes more than 300 variables, and the researchers selected 18 of them. Here are some descriptive statistics for variables. Totally, there are 9 Boolean variables, 5 string variables, and 4 decimal variables. And there are 319,795 observations in total. Next page, please. Actually, in terms of identifying research topic, we were initially entangled with research on the US avocado market or heart disease factors based on those two datasets. Compared with the study of American avocados, which may be limited to the use of unsupervised learning methods, the study of risk factors for heart disease can apply more supervised learning methods and has more practical significance. We finally decided to start the risk factors of heart disease based on this heart disease dataset. Next page, please. Here are some key assumptions we've made for the dataset. Firstly, the most important assumption in data processing is that the dataset is reliable, which means that the sample is randomly selected, so the data are representative. Secondly, we assume the people surveyed have truthfully disclosed their data, and no one has lied. For example, some people had the habit of smoking because of vanity. What's more, we assume the judging criteria for some variables of the surveyed population are the same. As a counterexample, the options for variable physical activity are only yes or no. There are some people who do not exercise, so they choose no. Actually, they communicate by bicycle every day. For others who only did that exercise once a week, which doesn't help, but in the survey they choose yes, which does not really reflect the situation. Both cases can affect the accuracy of the data set. Then Yawen will talk about the data cleaning.
Okay, let me introduce the data cleaning part to you. After we uploaded the data set, we got a data frame like that. Next page, please. First, the variables are of different types. We need to transform them into consistent ones. We created a list named pipeline stages that stores different functions for each independent variable. String indexes, encoders, and the vector assemblers are added in turn. Then we create a pipeline and feed it into our dataset. Next page, please. After that, we transform pipeline model into a new data frame. Here, the dataset is almost ready. Next page, please. Next, we will check whether the dataset is balanced. Using group by function, we can see that there are about 292 people with heart disease and only 27 people without heart disease. So we should balance the dataset. Here, we decided to use oversampling approach. We got the ratio and duplicate the minority rows and combine both oversampled minority rows and the previous majority rows together and get the new dataset named part data, which is balanced. Next page, please. After that, we selected useful columns for later use and named it ready data. And then we randomly split ready data into training dataset and testing dataset. Here, the data is fully ready for model construction, and my partner will introduce the model part. Next page, please.
Okay, and here I will start with the model part. Based on our problem statement, we take heart disease as the target variable, which is binary, whether you have heart disease or not. Therefore, we should focus on machine learning methods designed for classification. In this project, we choose 4 methods. Logistic regression is specifically meant for binary classification, and decision tree and random forest are two classic methods which work well with both continuous and categorical predictors. And the last method is mainly for comparison. Support vector machine works well with unstructured and semi-structured read data like text and image, which is actually not the case of our data set. We apply to see what will happen if we choose the unsuitable machine learning methods to predict. Then we assume that model validation will improve the performance of each model at some extent. Therefore, instead of checking performance of each model, then do the parameter tuning, we firstly do the model validation and then continue with the model valuation part. In this part, we test different sets of hyperparameters that these four machine learning algorithms use to train the model. Then we conduct five-fold cross-validation to create the best model in each machine learning method, where we use AUC as the evaluation matrix to check on the performance of our model. There are two reasons we choose five-fold cross-validation technique. Firstly, compared to leave-one-out cross-validation and bootstrapped, k-fold cross-validation is less computationally expensive. Leave-one-out validation and bootstrapped approach are usually used when you have small data sets. In our situation, we have a large data set, so k-fold cross-validation would be a better choice. Secondly, larger k means less bias towards overestimating the true expected error, but higher variance and higher running time. In practice, k equal to 5 or k equal to 10 have been empirically shown to be balanced bias and variance. Since our sample size is large, which means that we are at the fractal part of the learning curve, so we choose five-fold to reduce computational cost. The parameter we choose for each model are shown as this table. And now my partner will continue with the model valuation part.
And for model valuation, we evaluate the performance from two dimensions, both its performance and its computational cost. And to evaluate how well the model performs, we choose two main metrics, that is the area under ROC curve and the confusion matrix. And the ROC curve is created by plotting the true positive rate against the false positive rate. And the higher the AUC, the better the model performs. And here are the results of the AUC among different models. We can see from the table on the left, logistic regression and support vector machine is the best candidate model because of their largest AUC, and the decision tree perform worse because it just has an AUC of approximately 31%. And in general, random forest is still comparable with logistic regression and support vector machine. And next slide, please. We also use confusion matrix as our second evaluation method. And before evaluation, we find that our data set is very unbalanced. The ratio of the non-heart disease divided by the heart disease is nearly 10. Therefore, we oversample the minority and undersample the majority to make the data set balanced. And after this works, the accuracy is a good metrics. And we can say from the table, according to the accuracy, logistic regression and support vector machine performs the best. And also according to the FE score, we produce the same result. And however, if we consider the computational cost, logistic regression is the most efficient candidate model. And next slide, please. We also consider the computational cost as our second dimensional evaluation. And from the table, we can say that decision tree is the fastest model to produce a desired result. And the logistic regression is a second efficient model. The time random forest and support vector machine used is much longer. And in conclusion, logistic regression is the best candidate model after synthesizing multi-dimensional evaluation criteria. It stands to the reasons that the logistic regression is the most suitable when there is a binary result, including but not limited to whether or not the patient suffers from heart disease, which is very in line with the goal of our project. Next slide, please. And we also encounter some problems, like the result of the RUC confusion matrix and the computational time varies in each round. We see from the results that confusion matrix and AUC are not so different, but the computational cost among these 4 models is so different. We think it may be due to the fact that different computers have different features, so it's resulting in such different results. Yes, yeah, that's all. Thank you for your listening.